All right, so we have another word problem. This one is involving planes traveling on a windy day. So a plane makes a 7 hour, that should say 2,368 mile trips. Let me add that. 2,368 mile trip on a windy day. The wind is blowing at 20 miles an hour, and the question is, how fast does the plane travel in still air? So very first thing I see when we look at this, we have amount of time, we have a distance, and then we also have miles per hour, which is a rate. So you might be familiar with this equation. It means the following. It means distance equals, D stands for distance, distance equals rate times time. I think we may have done a problem similar to that in the systems of equations chapter, but so distance equals rate times time. So now we just have to fill this in. Now here's the challenge. We don't know how fast the plane is going in either direction. We know that on the way out the wind is pushing it maybe, and on the way back it's being pushed, or vice versa. We don't really know that information. So here's what we can do. We can fill this in, and we're being asked how fast. So we're being asked about the rate. So let's solve that equation. Distance equals rate times time. Because we're trying to find rate, let's solve it for rate. And we can do that by dividing by time. So distance over time is equal to the rate. Okay, that's what we can glean from that. Okay, and actually, let me take that back for a sec. Because it's a rational equation, we don't want to solve this for rate. We want to solve it for time, and I'll show you why in just a sec. So let's divide this by rate. Okay, so this becomes distance over rate equals equals time. Okay, so let's set this up now. So we have our outbound trip, and then we have our inbound or our return trip. And we have solved this for time. So hopefully this will make sense to you. The time going out plus the time coming back, or the time returning, that should equal the total time, right? I mean, that makes sense. If I'm taking 7 hours, then that means that consists of the time that it took me to travel to this place and the time that it took me to get back. So the total time is 7 hours, and that's going to consist of the time going out plus the time taken to return. Now here's the thing. If you look at this equation right here, we've expressed time as distance over rate. So I'm going to write the outbound time as the distance going out, okay, over the rate going out. And likewise with the return trip. Distance going out over the rate going out. Again, that's why we solve this for time, because they're telling us here 7 hours round trip. But obviously one of these trips is going to be faster, because one of them you had the wind pushing you, the other one you had the wind in your face. So the distance, well, it's 2,368 miles round trip. So that means the distance is going to be just cut in half for each trip. So that divided by 2 is 1,184 miles. So that's going to be our distance for both of these. And the rate, well, we don't know which one had the wind with us and which one had the wind against us. That doesn't really matter, though. So the answer will be the same whether the wind was with you going out or against you going out. So let's just assume that our plane speed, our rate, was being pushed along by the wind. So we're adding 20 miles an hour to our speed on the way out, and then suppose that we had it going against us on the way back. Okay, now that we have this is equal to 7 hours. Remember, this doesn't look like a time, but it is a time, because we're talking about, didn't want to clear those. We're talking about the rate right here, or the distance over the rate, which according to that equation it equals the time. So here's what we can do. We're now at the point where we can solve this like we were solving those other equations. Remember that we would find the common denominator, and then we would multiply both sides by that. So let's think about it. What's the common denominator? Well, you have an r plus 20 and you have an r minus 20. So we need to cover both of those. So r plus 20 times r minus 20 is our common denominator. So we're going to multiply everything by that. So r plus 20 times r minus 20 right here. R plus 20 times r minus 20 over here. Okay, now we're in a position to be able to start to distribute this in factor. So let's do that right now. So if we distribute this to the first thing, r plus 20s will cancel, and we'll have r minus 20 times 1184. So 1184 times r minus 20. And then same thing, if we distribute over here, the r minus 20s will cancel. We'll have r plus 20 times that 1184. By the way, there's a plus right there. So 1184 times r plus 20. Okay, on the other side, it would be easier to do this first, because that's a difference of squares. If you FOIL that, you'll get r squared plus 20r minus 20r, those will cancel. And then 20 times negative 20 is minus 400. And then we still have that 7. When we distribute the 7 there, we'll have 7r squared minus 7 times 400 is 2800. So that's what we have so far. Okay, now we can start to simplify. So let's clean this up on the left side. Let's start distributing these things right here. So if we were to distribute this, we'd have 1184r minus that number, I believe, turns out to be 23680. We'll distribute this. We'll have 1184r, and then we have plus 23680. So of course those will cancel. 1184r plus another 1184 would be 2368r. And then on the other side we have 7r squared minus 2800. Okay, now you might recognize this as a quadratic equation. So we'll have to put this in standard form, which we can do by subtracting that from both sides. So when we do this, we'll get 0 equals 7r squared. And then after that, we'll have minus 2368r, and then minus 2800. Okay, now it's possible that we might be able to factor this if I just want to see if 7 goes into all of those numbers. Let's see, 7 goes into that 3 times. 26, it goes into that 3 times. And unfortunately, it's not going to go in evenly, so that means we're not going to be able to factor this. So what we can do is we can use the quadratic formula. So we'll do that right now. So the quadratic formula is this. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And of course, because these numbers are so large, we'll want to wind up using a calculator for this. So we have b squared. I'm just filling in this quadratic formula. We're going to put the values in here as we go. By the way, hopefully it would make sense to you. We're solving for rate, and so we're not going to use any negative values here. It would not make sense to have a negative rate of speed. So a is equal to 7, so the a goes here and here. B is going to be equal to this number, negative 2368, so that's going to go right here, and it's going to go right here. And then finally we have C. C is equal to negative 2800. So we have that right there. And now we'll plug this into a calculator. Let's see if we can simplify this a little bit more first. So if we simplify this a little bit more, negative 2368, that would be positive 2368, plus or minus. Okay, and then obviously these are fairly large numbers. So negative 2368, that whole thing squared, turns out to be this massive number right here, 5,607,000. Using a calculator for this, 424. This right here, a negative times a negative is going to be a positive. And then what is this going to be? 4 times 7 is 28. 28 times 28 with 2 zeros would be 784 with 2 zeros, so 78,400. And then we want to add that to that number that we just got right there. So when we add, by the way, it's all over 2 times 7, which is 14. Okay, so when we start to simplify that, let's just simplify this down a little bit. This is going to be 2368 plus or minus this whole thing. When we add that and when we take the square root, it rounds to approximately 2,384.5. And then we're going to divide that by 14. So we don't need to do the minus. There's a plus or minus here. We don't need to do the minus, because if you did 2368 minus that number, you would get a negative, and we can't have negatives right here. So we're just going to find out what that is. So when we plug that into the calculator, which I'm doing right now, we end up getting that the rate is 339.5 miles per hour approximately. So that is how we would solve that distance, rate, and time equation.